Okay, let's talk about parametric equations. As you already learned about parametric equations in pre-calculus class, parametric equations are defined in terms of third variable, which is called parameter. For example, x is defined by t, like this, 3t squared plus 1. And y is also defined by t. Y is equal to 2/3 t to the third power. These are typical examples of parametric equations. In the first equation, x is in terms of t. In the second equation, y is also in terms of t. So in these parametric equations, t is third variable, which is parameter. Usually we use t or theta for parameter. Okay, then we need to talk about how to find first derivative of parametric equations. Yeah, just like what we had in this example, in parametric equations, x and y are defined in terms of t. So, to find the first derivative, which is dy over dx, we need to find dy over dt, which is derivative of y in terms of t, over dx over dt, which is derivative of x in terms of t. So, from the given example, we should find derivative of each equation. Both of them should be in terms of t. So first one, x prime of t, or dx over dt is 6t by using power rule. Second, y prime of t, which is dy over dt, is 2t to the second power. 2t to the second power, yes. Now we can find the first derivative, which is dy over dx. dy over dt, I said dy over dx in parametric cases, dy over dt over dx over dt. dy over dt is here. dy over dt, 2t squared. Then dx over dt is here, 6t. And then you simplify. 6 divided by 2. 2 divided by 6 is 1/3. And then t squared, 1. So numerator is t, denominator is 3. t over 3 is first derivative, which is dy over dx in terms of t. Okay? And next one, second derivative. Let's talk about definition of second derivative in parametric equations. Second derivative is d squared y over dx squared, right? So in parametric equations, d over dt, first derivative, dy over dx, over dx over dt. This is definition of second derivative. You better memorize this. So d over dt, what is dy over dx? That one is first derivative, right? That one is first derivative. So use first derivative t over 3. Yes. And then dx over dt is here, 6t. So use 16 denominator. Okay. All right. What is first derivative? What is derivative of t over 3? You should make another derivative in terms of t. So 1/3. Denominator, 6t. So it's going to be 1 over 18t. 1 over 18t. 1 over 18t is second derivative. Okay, let's try question number 5. A curve is described by parametric equations. X equals t cosine t and y equals t sine t. Find the equation of the line tangent to the curve at the point determined by t equals pi. t equals pi. T is parameter. Okay, to find the equation of tangent line, we need to use point slope form, like y minus y1 is equal to slope m times x minus x1. Let's find x1 and y1 first. x1 and y1 are xy coordinate of tangent point, right? Tangent point, x1, y1. x1 is, how can you find x1? X equation is here, right? So you just plug in pi for each t. X is equal to pi times cosine pi. Cosine pi is -1. -1 times pi is -pi. So x coordinate is -pi. X value of tangent point is -pi. And then plug in pi for these two t to find y coordinate. Pi times sine pi. As you know, sine pi is 0. 0 times pi is 0. So y equals 0. We found tangent point. And then we need to find m. M is slope of tangent line. Slope of tangent line is dy over dx. But this is parametric case. So dy over dx is dy over dt over dx over dt. Yes, let's find dx over dt first. X is here. X is t cosine t. So you differentiate this equation, both sides of the equation in terms of t. So dx over dt is, and the right side use product rule. Derivative of t in terms of t is 1, and then cosine t plus you keep t. Derivative of cosine t, which is negative sine t. All right, that's dx over dt. And then we need to find dy over dt from y equation. Y is t sine t. Dy over dt is equal to product rule. Derivative of t is 1, and then sine t plus keep t. Derivative of sine t, cosine t. And then we are looking for dy over dx, which is dy over dt over dx over dt when t equals pi. That's given condition, right? So you plug in pi for each t. All right, you plug in pi for each t. So it's like cosine 1 times cosine pi plus pi times negative sine pi. Sine pi is 0, 0 times pi is 0. Cosine pi is -1. So dx over dt when t equals pi is -1. And you also plug in pi for t in second equation. Sine pi plus pi times cosine pi. Sine pi is 0. Cosine pi is -1. So negative pi. dy over dt is negative pi. Dx over dt is -1. So slope of tangent line is -pi over -1, which is pi. So you plug in pi for m, and -pi for x, 0 for y. So the answer is y minus 0 is equal to, slope is pi, pi times parenthesis x minus -pi. So y minus 0 is just y, pi times x, negative is positive. This is answer. Not very hard. Let's try one more question. Number 8. A curve is defined by parametric equations. X in terms of t is at squared plus b, and y in terms of t is ct minus b, where a, b, and c are non-zero constants. What is slope of line tangent to the curve at the point xt, yt when t equals 2? You just need to find slope of the line, slope of the line tangent. So tangent line, slope of tangent line. Yeah, dy over dx. But this is parametric case. So dy over dx should be dy over dt over dx over dt when t equals 2. Okay, let's find dy over dt first. Starting from y equation, y in terms of t is ct minus b. So y prime of t, which is dy over dt, is just c. And then find dx over dt. X equation is, x in terms of t is at squared plus b. So x prime of t, which is dx over dt, is equal to 2at. Okay, 2at. So dy over dx is dy over dt, which is c, over dx over dt, which is 2at. But we are looking for slope of tangent line when t equals 2. So you plug in 2 for this t. So the answer is c over 4a. 2 times 2 is 4, 4a. That's the answer.